Hello everyone, welcome to the Success New Home Tutor. Till now we have learned in our first chapter the electric charge and the electrostatic field. That is how the charge take place and how the electrostatic field is created. Okay, so today the topics that we are covering is basics of charge. That is, what is charge, then its unit, symbol, its type, their properties and direction. Next part is conductors and insulators. What are conductors, what are insulators, their properties and the difference between both of them. Next is charging by induction. Till now we have covered or we have seen the charging by rubbing action. Now we will see the charging by induction. And the last part is properties of electric charge. That is, what are the properties like additiveness, its conservative property, its quantization property and so on. Okay, so first we will see the basics of charge. Now what is charge? It is the property of matter that causes to experience the matter itself the electrostatic force when there is a new electric charge which is near to the first one. Okay, so this is electric charge and they falls into two categories, positive charge and negative charge. It is observed from experiments the like charges repel each other and unlike charges attract each other. And this is due to the field around these charges. The field is electrostatic field. Why this the dictionary meaning of electrostatic is static means that rest, that is charge at rest. So the electric field that is operating on the charge which is at rest or which is static. The unit of the charge is coulomb and its symbol is capital Q or small q. Charge is a scalar quantity, that is it has no direction. Also there is a property like conservation and quantization. Okay, so now there is a new concept, conductor and insulator. When some bodies are rubbed with another body, they get charge, but some bodies do not get charge. The bodies which get charge are called conductors. So the example for conductor is metals, animal body, humans, earth, etc. And the other other category is called as insulator, like wood, nylon, plastic, glass, etc. When the charge is transferred to the conductor, it gets readily distributed over the surface. Okay, so what is conductor? It conducts the electric charge. Okay, and the insulator means it resists the electric charge. The insulator does not amount the movement of the electron, support the movement of the electrons, that is why they are called insulator, which is similar to the dictionary meaning insulate. There is third category also, that is semiconductor, which is intermediate between conductor and insulator. But that we will see in next part. Okay, so there is a new concept, earthing. Same, it is known as grounding also. When a charged body brought in contact with earth is a positive conductor. Okay, right now we have learned that earth is a conductor. So when a charged body brought in contact with earth, all the excess charge on the body, excess charge means that is moving around it, that which is moving around it disappears and there is a current which pass to the ground is earth after connecting a conductor. This process of sharing the charges, with the earth is called earthing or grounding. Earthing provides safety measure for electric circuit also, appliances also, etc. What are the appliances? Like TV, refrigerator, electric iron, etc. Now we will turn to the diagram. Okay, Here it is an object which is mounted on insulator and it is negatively charged, that is excess negative charge, and in this object there are excess positive charge. Obviously it is mounted on insulator stand. Okay, so here the grounding or earthing means making object neutral or uncharged, and if the object is negatively charged like this, it takes the electron to the earth. Okay, and if it is positively charged, there is a movement of electron from earth to the object. Okay, so this is called as earthing and or grounding, and it is useful in electricity wiring. Okay, so that in detail that will be covered in next chapters. Okay, now we will learn charging by induction. Till now we have learned the charging by rubbing action. Now we will see that there is no any contact or no rubbing between the two objects. First of all, two metal spares are taken and they are mounted on insulating stand and they are brought in contact with each other, and by charge they are neutral. There is no charge or charge on those bodies. Now a positively charged rod is brought near to the first metal sphere. Okay, as this is a positive charge, there is an induction of negative charge on the right side of the sphere. Okay, so it is negative charge, and to this part of the sphere there will be obviously a positive charge. Okay, so this is positive charge, this is negative charge. Now in this side of the sphere there will be positive charge. Now again, by the property of the electrons, as here there is a positive charge, here there will be a negative charge, and due to the distribution there is again positive charge. Okay, now this is a induction, that is no contact, just by inducting the charges. Now we will see here that when the rod is removed and when the both metal sphere are separated, they retain charges. Okay, so first of all the metal charge were inert, now there is a charging, and after separating them again they are charged. So this is called as charging by induction. The magnitude of force which depends on the distance between will be dependent on the distance between charges. Okay, now we will turn to the basic properties of electric charge. Okay, the first property is additivity of charge. Now consider that there are 2 point charges, that is Q1 and Q2. So the total charge will be Q1 plus Q2. This is because, like real numbers, the charges get added. Okay, and also they are scalars like mass of the body. Now if we consider the above example, if we take n charges, that is Q1, Q2, Q3 up to Qn, so the total charge will be Q1 plus Q2 plus Q3 up to Qn. Charge has magnitude but no direction, which is similar to mass. However, the mass is always positive and the charges may be positive and may be negative. By taking this into consideration, if there are 5 charges like plus 1, plus 2, minus 3, plus 4 and minus 5 in some arbitrary unit, the total charge will be 1 plus 2, that is 3, plus minus 3, that is 0, plus 4, that means 1, and minus 5 means minus 1. So the total charge will be minus 1 in the same unit. Now we will see the second property of charge. The charge is conserved. Now when the charge is induced or by rubbing action the charge is produced, there are new charges on the body, but here we have to consider, we have to confirm that there is no charge is created and no charge is destroyed. Charges may redistributed around the material but the total system is isolated. The total charge on the system is 0 before and after the creation of charge. Now the third property is quantization of charge. Experimentally, it is established that all the free charges are integer multiple of basic unit. So if we have to write down in an equation, then we can write Q is equal to Ne. Q means the symbol of the charge, N is any positive or negative integer, and E is a electron. Okay, so the basic unit of the charge on the charge will be negative or positive. It is by convention it is taken. Okay, so the fact that electric charge is always an integral multiple of E, that is electron, is termed as quantization. Quantization means the quantity, and quantity is obtained by the integer n. Okay. Thank you for watching our video, and don't forget to like, share and subscribe Success Educator. Thank you.